No, there's only one answer to this, yeah. Which is why I have to tell you degree 5. You're supposed to give me the function that draws that curve.
Got it.
Okay. If you finish, you can bring it up here. Feel good? Thank you, sir. Thank you. Thank you. Yeah.
So, did you mean, I forgot what you said at the beginning. You said, do you want it to foil or not
No,
foil?
just like that. Okay, it's good. Okay, thank you. I think 2 more minutes is fair. Thank you. Thank you.
Where are they my test? Or not what test, but place?
Right here? Thank you. Okay, that's time. Please turn in what you have. Thank you. Thank you. Thank you. Anybody else? You did not have to FOIL it out. We're going to go over the quiz. Let me see here. I'm going to separate these. All right, we good? That's everyone? Okay, so 5 people got it right. 5 people got it right. So let's go over it, all right? A few things I'll say before, a little tough love here. If I tell you I'm going to have a quiz and I say it's going to be over this, you should be prepared for that. And if you're unsure, that's why I have a camera in the back of the room, so you can go back and watch the lecture, right? So you can prepare for the class, right? So I promised you that I would give you a graph. We went over a few of these in class last time, right? But I still think there's some confusion, all right? I'm not blaming this all on you. Let's make sure we clarify the concept. What we're looking at is a polynomial, right? It's a 5th degree polynomial. So you know that the function must look like, well, a bunch of things, you know, raised to powers in parentheses, right? Each of those factors comes from where? The x-intercepts, right? So what are the zeros of the x-intercepts of that thing? I'm going to list them over here. What are the zeros? What is it? -3, -1, and 2, right? Those are the zeros or x-intercepts. Now, what's the multiplicity of each of these? Remember, we talked about that as well. Where do we get that from? If it crosses or bounces, right? So the multiplicity. So what's the multiplicity at -3? We cross through, right? We cross through, so it's odd. Now we don't know exactly what number it is. It could be 1, it could be 3, it could be 5, right? Let's just keep going. What's happening at -1? We're bouncing off, right? So that means it's going to be an even multiplicity. How about at 2? Even as well, because we're bouncing. Any questions there? Our total degree has to be 5. There's only one way to get 5 from this, because you have 2 even powers, right? And 1 odd. So it can only be 2, 2, and 1. There's no other way to do it. So these add up to be 5, right? These add up to be 5. So now what I do is I come over here to create the function. Now this is the part I think is still misunderstood. There's some number in front that I don't know. That controls the stretch or the flipping of the graph, all right, which I will illustrate for you in a second, all right? So I know that my first 0, x minus 3, means that I must have a factor x plus 3, right? And that must be to the first power. This factor must be to the first power. Then I use this 0, right? X plus 1. You're doing the opposite, right? You're doing the opposite. Why? Because if I plug -3 right here, what happens? -3 plus 3, 0, right? And that would give me a 0, which is what's happening there, right? X-intercept. And then this one should be raised to what power? Second power right there. And then I do this one, the opposite, x minus 2, and then again, I square it. Okay, that right now, if you got that, you're not going to get a 0 on the quiz. If you got that, you're going to get some credit, all right? But were you able to determine A? So what I'd like to do is I'd like to show you, because I was with a student this morning, and we went over this, and when I showed them, that it really helped them to see this. So I'm going to, on Desmos, I'm going to graph A times, I'm going to graph this, A times x plus 3 times x plus 1 squared times x minus 2 squared. And then Desmos allows me to control the A. So take a look at the blue graph here, all right? And you know what, let me do one more thing. Turn that graph off. Okay, so what you see right there in blue is this function with A being controlled by me, all right? And do you see that the point 1, negative 32 is not on that graph right now? But if I change the value of A, oops, shit. Can y'all tell what A is right now? See it right here? What's A? 1. Do you see that's not going to work? But if I start to change the value of A, do you see how it changes the shape of the graph? I need to figure out the value of A that would make it go right through that point. Do you see that? Yes.
So A will change the shape of the graph?
It changes whether or not it's stretched out or flipped over.
Okay.
Yes. Exactly. So the question, I just want to make sure everyone understands this is what we're trying to do, right? This is what we're trying to do. We're trying to figure out the A. Right now, there's an infinite number of answers right now until I give you that point. As soon as I give you that point, there's only one answer. It's the graph that goes right there. Oh, shit, I missed it. I had it and then I lost it, but there we go. That's the one, right? That's the one. You can tell the answer. See, it's negative 2? But let's see how we would get it here. So now I say, but I know that when I plug what in? 1, that the function should spit out the number negative 32. So that means if I go into this and I plug in 1 for x, 1 for x, 1 for x, the answer should be negative 32. So let's do that. Let's plug 1 into this. I have the A sitting in front, 1 plus 3. 1 plus 1, what? Squared. And then 1 minus 2 squared. That must be negative 32. And now I just do this arithmetic. A, 1 plus 3 is 4. 1 plus 1 is 2. 2 squared. 4. 1 minus 2. Negative 1. What's negative 1 squared? Positive 1. Equals negative 32. All right, what's 4 times 4 times 1? 16. So this is 16a equals negative 32. Divide both sides by 16. A is negative 2. I saw some of you got A as 2. You know, I'll take a look. When I said there was 5 people that got it right, there was 5 people that got A is negative 2. All right. So a few of you I saw got 2. I'll take a look when I grade it. All right. Does that make more sense?
Yeah.
Yes? Okay, that should make that much sense to you when you walk in here to take the quiz, not after the quiz. Yes?
You said we were going to go over synthetic division last class. You get this problem.
Yes?
I remember you said we'll just get a point.
Yeah, well, we started to talk about synthetic division last time.
Yeah.
Yes. We're going to continue today. All right, so good? Can we proceed? All right. Let me bring up the notes. We're working on these problems. Where's the eraser? Where's the damn eraser? Okay. All right, so do you remember these problems from last time? We said we're going to try and graph all these, right? Check, did we do G1? I feel like we did G1. We did G1?
I don't think we did,
No?
no.
I think we did. Yeah, because I said grouping won't work, right? Okay. All right, so we did it, right? We finished that problem, though, completely. Right, synthetic. So we're going to move on to H1 now, all right? And look, the problems I'm doing up here are really like the ultimate goal of what I want you to be able to do. Like the quiz today, I felt the quiz today was an opportunity for you to do well because I thought it was a pretty straightforward quiz. This is what you're going to have to do more on the test right here, all right? The quiz is really just so you understand like the connection between the zeros and the bouncing and the crossing and that the A is important and all that. But ultimately, we want to be able to graph this. So let's look at this. H1 of x equals x to the 6th minus 9x to the 5th plus 17x to the 4th. All right, plus 33x cubed minus 90x squared. All right, so what we want to do is sketch this. We want to graph this, all right? I want the picture of this. So the first step to sketching right? Did I give you all steps last time? I don't think I gave you the formal steps, did I? Yeah, let me just put the steps over here, all right? Because they're real simple. All right, how to sketch a polynomial function. Okay, first step, find the end behavior. And to do this, we use the leading coefficient test. That was that thing where we used the table, right, to figure out the up, down on the sides. That's the first thing you do. The second thing you do is you find the x-intercepts and the multiplicities. In other words, you're going to figure out where the graph touches or bounces. Crosses or bounces. And then your third and final step is to draw it, okay? Sketch it. Okay, sketch it. And the second step is always the hardest step. That's always the hardest step. Because to find the x-intercepts, you have to set the function to 0, and that means we have to factor. Okay, so let's do step 1. So for step 1, I look at what? The leading coefficient test says I need to look at what? The degree, okay, the degree. So the degree is right here, right? The highest power of x that we see, right? So the degree is 6, and that's an even number, right? That's what we're concerned with. I'm trusting that you have that table drawn somewhere in your notes. The degree is even, and then we look for the leading coefficient. The leading coefficient is the number that is in front of that highest power of x, which for us is 1, right? So the leading coefficient is 1, and that is positive. So you look at your table. What happens when you have an even degree and a positive leading coefficient? It tells you that the left side does what? Left side goes up, right side? Up, and in the middle, we don't know, right? It's going to do all sorts of things. Okay, that's first step.
And then you said that the greatest exponent is the greatest amount of zeros we can have.
Yeah, 6 is the most number of x-intercepts we could have, but
It's not.
but that's kind of actually, well, no, I'm not going to. So 6. See, we don't talk about imaginary numbers, right? So if you included imaginary numbers, then there are exactly 6 answers every time. Like whatever the degree is, that's how many answers there are. But if we're only talking about real solutions, then it's going to be 6 or less. All right, second step, find the x-intercepts, right? Set the function to 0, which when you look at this is extremely intimidating, isn't it? When you first look at it, it's like, whoa, I'm supposed to figure out where that thing is equal to 0. And we have to factor, right? We have to factor. So the first step of factoring anything is GCF, greatest common factor. Always look to see if you have something in common. And these all have x squared, right? Every single one of these has x squared. So I'm going to pull the x squared out front. Do not forget about that x squared. It's going to be there for the rest of the time. That reduces the power on all of these x's, right? Everything comes down by 2, all the powers. And it's in parentheses, right? And there's that x squared out front. Let me make sure I'm recording. I'm pretty sure. Sure I'm not muted. Yeah, yeah. It's recording, but let me do something because I had the